Energy is the currency of life, and the little power plants inside your cells, called mitochondria, are the ultimate source of it. Without healthy mitochondria, even simple tasks can feel exhausting. Recovery from exercise can take longer, and the process of aging can accelerate. Scientists are now finding that the health of your mitochondria is not only linked to how you feel today, but also to how you will age over the next decades. The exciting part is that you can train and nourish your mitochondria in ways that supercharge energy production, improve endurance, and even slow biological aging. Mitochondria are small but mighty structures inside almost every cell in your body. They convert the food you eat and the oxygen you breathe into adenosine triphosphate, or ATP, which is the molecule that powers every movement, every heartbeat, and every thought. When mitochondria are efficient, you feel vibrant and strong. When they are damaged or fewer in number, you can experience fatigue, brain fog, and slower recovery. Over time, mitochondrial decline is one of the hallmarks of aging. The good news is that research from journals such as Cell Metabolism and Nature Aging shows that specific lifestyle interventions can improve mitochondrial health at any age. One of the most powerful ways to enhance mitochondrial function is through the right type of exercise. Not all workouts affect mitochondria in the same way. Zone 2 cardio, for example, has emerged as a leading method for increasing mitochondrial density. This is a form of moderate intensity endurance training where your heart rate is kept at around 60 to 70% of your maximum. At this pace, you are breathing a little heavier than normal, but can still hold a conversation. Activities like brisk walking, cycling at an easy pace, or swimming steadily for 45 to 60 minutes fall into this category. Studies show that this type of training triggers mitochondrial biogenesis, which is the process by which your body makes more mitochondria. More mitochondria mean more energy production capacity and greater resilience against fatigue. While Zone 2 training is excellent for building the foundation of mitochondrial health, high-intensity interval training, or HIIT, can take things a step further. HIIT involves short bursts of intense effort, such as sprinting or cycling at maximum speed, followed by brief rest periods. Research indicates that HIIT stimulates both mitochondrial biogenesis and mitochondrial efficiency. This means your existing mitochondria become better at producing energy, and you also build new ones. The alternating stress and recovery in HIIT signal your cells to adapt and strengthen their energy systems. Even just 10 to 20 minutes of HIIT 2 or 3 times per week can lead to measurable improvements in mitochondrial function. Resistance training, often overlooked in discussions about mitochondria, also plays a crucial role. Strength training stimulates the production of muscle proteins and improves insulin sensitivity, which indirectly supports mitochondrial health. Muscles with more mitochondria are better at using fat for fuel and at clearing out damaged components through a process called mitophagy. This is essentially the recycling of old, inefficient mitochondria to make way for fresh, high-performing ones. Lifting weights, performing bodyweight exercises, or using resistance bands all contribute to this process and can be combined with cardio for the best results. Now, exercise is only part of the equation. What you feed your mitochondria is equally important. Certain nutrients act as direct cofactors in energy production or help protect mitochondria from damage. Coenzyme Q10 or CoQ10 is a prime example. It is a molecule that resides inside mitochondria and plays a critical role in the electron transport chain, the final step in ATP production. Without enough CoQ10, this process slows down and energy levels drop. Supplementation has been shown to benefit people with mitochondrial disorders, but even healthy adults may see improvements in energy and recovery, especially as natural levels of CoQ10 decline with age. Here is something that might surprise you. Fasting and calorie restriction can also promote mitochondrial health. Short-term fasting activates autophagy and mitophagy, processes that clear out damaged cellular components, including old mitochondria. This creates space for new, more efficient ones. Research in Nature Aging suggests that periodic fasting or time-restricted eating can mimic some of the cellular benefits of exercise, especially when it comes to maintaining mitochondrial quality. It is not about starving yourself, but about strategically giving your body periods of low nutrient intake to trigger beneficial adaptations. Now imagine this. You wake up feeling alert, your muscles recover quickly after workouts, and your mind stays sharp well into the evening. This is not just the result of caffeine or good sleep. It is the daily payoff of strong, efficient mitochondria working behind the scenes. When your mitochondria thrive, everything from physical performance to mood regulation improves. It is like upgrading the battery in every single one of your cells. Sleep quality is another often underestimated factor in mitochondrial function. During deep sleep, your body repairs cellular damage and restores energy reserves. Poor sleep disrupts this process, leaving mitochondria vulnerable to cumulative stress. Sleep deprivation has been shown to increase oxidative stress within mitochondria, impairing their ability to produce ATP efficiently. Prioritizing 7 to 9 hours of restorative sleep each night gives your mitochondria mitochondria the time they need to recover and regenerate. Managing chronic stress is equally vital. Elevated cortisol over time can disrupt glucose metabolism and promote inflammation, both of which can harm mitochondria. Practices like mindfulness meditation, deep breathing exercises, or spending time in nature have been shown to reduce stress markers and support healthier cellular energy production. Think of stress reduction as giving your mitochondria a more stable, predictable environment to operate in. There is also an environmental dimension to mitochondrial health. Exposure to toxins like heavy metals, pesticides, and air pollution can damage mitochondrial DNA and disrupt their function. Choosing organic foods when possible, filtering your water, and reducing exposure to household chemicals can reduce the toxic load your mitochondria face. Supporting your body's detoxification systems through regular sweating, either from exercise or sauna use, is another way to help protect mitochondrial integrity. One fascinating aspect of mitochondrial biology is that these tiny structures have their own DNA, separate from the DNA in your cell nucleus. This mitochondrial DNA is more vulnerable to damage because it lacks some of the protective mechanisms of nuclear DNA. When mitochondrial DNA is damaged, the energy production process becomes less efficient, leading to a cascade of cellular dysfunction. This is why strategies that reduce oxidative stress, like antioxidant-rich diets and regular exercise, are so important in maintaining mitochondrial genetic stability. Scientific studies have repeatedly shown that mitochondrial decline is not an unavoidable part of aging. In one study published in Cell Metabolism, older adults who engaged in regular aerobic exercise had mitochondrial capacity similar to that of much younger individuals. In another study in Nature Aging, interventions like calorie restriction and nutrient supplementation slowed markers of mitochondrial deterioration in animal models. These findings underscore that lifestyle choices can directly influence how well your mitochondria perform over time. The synergy of combining exercise, targeted nutrition, stress management, and environmental awareness is what leads to the most profound results. A person who incorporates Zone 2 cardio for mitochondrial density, HIIT for mitochondrial efficiency, resistance training for muscle-driven energy metabolism, and nutrient support from CoQ10, creatine, and polyphenols is giving their cells a comprehensive upgrade. Add in quality sleep, periodic fasting, and stress reduction, and you have a recipe for sustained energy, faster recovery, and a slower aging process. To put this into perspective, think of elite endurance athletes. They are not just genetically gifted, their training and nutrition have created a massive network of high-functioning mitochondria. This is why they can sustain high levels of output for long periods. While you may not be training for the Olympics, you can still apply the same principles to dramatically improve your own performance and health. Your mitochondria are listening to every choice you make. Treat them well, and they will reward you with more energy, faster recovery, and resilience against the wear and tear of time. This is not just about living longer, it is about living better with the strength and vitality to fully engage with life at every stage,